All right, so now that we've gone over the theory of what it is we're going to put together, Logan, let's get started.
All right, well, that's going to begin with a new project. So inside of Visual Studio, we'll make a new XNA Windows game for XNA 2.0. This game we'll call Starfield Test. So we had done sprite test before, so
okay,
Starfields.
I see your logical thinking.
All right. The first thing we want to add to this Starfield Test project is a Starfield class. And I'm going to organize that into a classes folder. So we'll begin with the folder classes. And now to this classes folder, we'll add the heart of the entire project. We'll add a new class. That is going to be our Starfield. Alright, so here's our Starfield class. What things are this class responsible for? Well, it needs to be able to hold a texture 2D, because the Starfield is, of course, going to be drawn as a texture. Mm-hmm. It needs to be able to write star pixels into that texture upon creation, so we have a procedural generation of its held texture. And then upon draw, we need to draw those stars on screen and make sure that they scroll in a downwards direction based on time. So those are going to be the goals of...
I got you. So that means it needs to probably be in just the Starfield test namespace, and we probably need to put some usings in there so that it is aware of XNA.
That'd be a very good idea to start with. So let's do just that. I've taken off the classes sub namespace, and we'll add a using for Microsoft.xna.framework, and also xna.framework.graphics, because, like I just said, we're going to be working with things like a texture 2D, so we need graphics types available to us. So to get the Starfield class itself kicked off, let's add some fields to it.
I bet the first one's going to be a texture.
How did you guess?
Well, because we're going to need one.
No, we're going to have a private field for the texture. The type will be texture 2D, and we'll simply call the field texture. Another field that I'm going to store inside of the Starfield is a speed value. Now, we'd only touch on this slightly on the whiteboard, but we did mention that the stars are going to be moving.
Right.
So it'd be very convenient to remember how fast they should move and make that value adjustable. So we're going to make a private field of type float called speed. Now, one other field that I'm going to store is we had noted that the stars are going to be placed into the texture based on a probability. That way we get a kind of random dispersal. And I'm going to need an instance of random in order to accomplish that. Now, because of the way this is going to work in the end, because I want, if we ever run into a scenario where multiple starfields are created, I want each of those starfields to be somewhat different. Mm-hmm. So I want to have an instance of random that lives on for any number of starfields. That means I'm going to make the random field static.
Okay.
Because again, we just want new random numbers. We don't need to have a random generator that's specific to each instance.
Right.
So we're going to make a private static field of type random. And to avoid needing to throw down a static constructor, actually let me name this first, random, before I forget. Now, instead of needing a static constructor, I'm simply going to initialize this with a field initializer. So right off the bat, we'll say that random is equal to a new instance of random. I'm not going to worry about seeding it because it's not incredibly important that this be unique on every run.
Okay.
Now, with these fields in place, we can take a look at some of the skeletoning for the Starfield class. The Starfield is going to consist of a public constructor and a draw method. And the keys to each of those are going to be the parameters used. And there's quite a few for each. So let's start with the constructor. The public constructor, so public Starfield. All right, we're going to need to take in several things. The first thing that we'll need is a graphics device. The reason we'll need a graphics device is because we need to feed an instance of graphics device over to the texture 2D constructor. After that, we'll use the rest of the parameters to describe the Starfield itself. That means we'll take in things like a width, a height, a density to control how many stars are used, a speed to control how fast the Starfield moves, and a color to use to draw, or so we can set the color of the individual stars.
Okay.
So to put these in as parameters, we can begin with the graphics device, and I'll simply call that graphics device. Then we need a width and a height, which I'll specify using integers. After that, we'll have our density. I'm going to specify density as a float. So float for density. And after that, let's see, we have our speed value, and I'm also going to specify speed as a float. And one last parameter is going to be the color of the stars themselves. So I'll have a color parameter that we will call color. So quite a few parameters in the Starfield constructor. And now, since this is just the skeleton section, I'll move on to the draw method. And this is going to be a public method, void return type, which we'll call draw. And draw needs to take in first a sprite batch to perform the actual drawing with. And since we don't have an update method in order to move the Starfield, we're only worried about where the Starfield's at on draw. It's not an interactive element. It doesn't have to be updated every tick, but it does need to be aware of the overall game time so it knows how far its offset should be. It's simply going to offset itself by time.
Right.
So that means at the time of the draw call, we're going to feed in the game time value. So we'll give it a game time parameter. And then two other things we need to know when drawing is what are our screen dimensions? How large should we scale the Starfield in the final draw call? We'll specify that using integers for width and height. So that way back in the game class we can specify something like the screen width and height, and that's where we get our scaling value from. Now I'm going to build just to make sure that I haven't introduced any syntax errors. And now let's take a look at setting up the game class, because it'll kind of help to have an idea of the properties that are going to be used to feed the Starfield before we start building it.
Okay.
So to move over to the game class, we'll begin with some fields. The first two fields are simply going to describe the screen resolution. So as we have done in the past, we'll make two constant integers called screen width and screen height. Screen width we'll set to 800, and screen height we'll set to 600. So this is screen height. Alright, now for some Starfield relevant properties. The first two properties I'm going to call the Starfield resolution, because of course the Starfield itself has a texture size. We'll describe that as the resolution, because a higher resolution Starfield would mean smaller stars, and a lower resolution Starfield would mean larger stars.
Because in the end it's getting scaled up.
Exactly. So the first of these two will be Starfield resolution X. Starfield resolution X. We'll set this to a value of 256, and then the field following this will be Starfield resolution Y. We'll set this to a value of 192. Now, why are we using the numbers 256 and 192? Well, these are roughly equivalent to 1/3 of the screen width and height. I think 800 divided by 3 is something like 266 point some decimal.
Yeah.
And then 600 divided by 3 is like 200 or something.
Mm-hmm.
So very close to this using, you can say, standard power of 2 texture sizes. And towards the end of this Starfield series, we'll probably even take a look at having the Starfield auto-scale based on the size of the screen. For now, I'm plugging in exact numbers just so we have a very concrete idea of exactly how large the Starfield is, because I do want to show this in a few different modes before we display the final full-screen version.
Okay.
All right, moving on from here, the next field I'd like to set to describe the Starfield is the Starfield's density. And we'll set this as a float. So we have Starfield density. We'll set that to a value of 0.001. Why such a low value? Well, if we think about it, a value of 1, based on the way we're going to run the probability, would mean make every pixel white.
Because the random number you generate, if it's less than this density, as I was talking about in the theory lecture, we're going to light up that pixel.
Exactly.
So everything would be less than 1.
Exactly. Now, if we had set this to a value of 0.1, this would mean 1 in 10 pixels should be colored. But that's still going to be so many pixels it'll look more like TV static than a Starfield.
Right.
0.01, so every 100th pixel. Well, that'll be nice and sparse, but still many, many stars.
Right.
1 in every 1,000 pixels should be nice and sparse.
Mm-hmm.
All right. Moving on from here, we have the speed field that we're going to store. This will again be a floating value. We'll call this Starfield speed. And we'll set this to a value of 2. All right, moving on from here. The last field is going to describe the Starfield's color. So make a color field. LT. Starfield color. We'll set that to the color white to begin with. And then one last field is a field that will hold an actual running instance of a Starfield. So you can make a field of type Starfield, and call the field also Starfield. And that takes care of our fields inside of the game class. We can move on from here to the the game's own constructor to make sure that this resolution, screen width, and height is taken into account, just in case we want to play with different resolutions. It'd be nice to have the game's own resolution keep up. So we'll look at the graphics. Tell the graphics preferred back buffer width to be equal to our screen width, and the graphics preferred back buffer height to be equal to our desired screen height. Alright, moving on from here. Now we need to look at the creation of the Starfield itself. And I'm going to have the Starfield instance created inside of load content, since generally this is where textures are loaded in and put together, so we'll actually make the Starfield and its associated texture in here. So what we'll do is we'll look at our Starfield field. If I can type the word star, and there we go, Starfield is equal to a new instance of Starfield, and we have several parameters to satisfy. First of which is a graphics device, which we can look at this game's own graphics device property. So we'll feed that along. Next is the width, and since we have several parameters, I'm going to put each of these parameters on their own line, so I'll jump down a line and tab over. Now for width, that was given in the Starfield width field.
Starfield Resolution X.
Exactly. So Starfield Resolution X for width, Starfield Resolution Y for height, Starfield Density for the density parameter, Starfield Speed for the speed parameter, and Starfield Color for the color parameter. So after all the artist naming in the fields, this makes the constructor much more easily to call. Alright, that takes care of the construction of a Starfield. Now I just need to worry about the drawing of the Starfield, which will be accomplished inside of the draw method. Before we draw the Starfield itself, we'll look at the sprite batch and make sure we make our calls to begin and end. So sprite batch will end, and between those calls, we'll take our Starfield and we'll tell that Starfield to draw. Now, of course, draw is going to need several things. First is simply the sprite batch. After that, it needs to know the game time, because here's how it's going to animate itself, is based on time. Now, fortunately, inside of draw, we are ourselves as a game class given the current game time. So we'll simply pass that along to the Starfield. Now, for the width and height, we would like the Starfield to be drawn to the overall screen resolution. So that means we can feed in screen width and screen height. So that ends off our call to Starfield.draw.
So let's go ahead and build real quick. Very good. And now it's time to focus on the heart of the Starfield.
Exactly, because up until now, the Starfield itself is just a skeleton. Nothing actually happens in the constructor. So let's flesh out the constructor and provide an implementation. Inside of the Starfield's constructor, the very first thing we're going to do is to simply remember the given speed, because we need to remember speed continuously since the constructor gets called once, and then after that we call draw a lot, and we need to remember what that speed value was. So this dot speed will be set to the given speed parameter. If you remember, of course, speed is over here as one of the parameters given to the Starfield. Alright, the next thing to do is to create the Starfield's texture. We have our texture field, but we need a new instance of texture 2D. So you could say that this dot texture is equal to new texture 2D, and here we need to satisfy yet more parameters, first of which is a graphics device for the texture 2D itself, and that we have given by the graphics device fed to the Starfield constructor. After that we have a width and a height, and we'll simply pass along the width and height parameters. The number of levels, this is of course meaning the number of levels used for the mip-map, were we to make a mip-map texture. Now mip-mapping is useful when the texture is scaled down, because the mip-maps are smaller and smaller versions of the same texture. And here we're scaling up and not down, so a mip-map would not be useful to us. So I'm going to specify the number of levels at 1, instead of allowing it to be auto at 0, since we know that we're only going to scale up and we'll never need mip-maps. The texture usage is going to be none, because I'm not looking for any type of linear tile. We're not doing any Xbox 360 drawing, and we're not generating a mip-map, because we don't need one. We won't have a use for one. Alright, the final parameter to feed to the texture 2D is the surface format. And I would like a surface format of color, so that these pixels will nicely fit into a color array, giving us access to things like red, green, blue, and alpha components. And that finishes off the call to the new instance of texture 2D. The next thing we need to do is to turn around and figure out how many pixels we'll have, so that we can in turn create an array of that many pixels. So I'll make an integer variable that we'll call pixel count. I'm going to jump back up a line as well. So integer pixel count. And pixel count is going to be equal to the given width times the given height. And now that we know how many pixels we have, we know how many elements to make our pixels array. So what I'm going to do here is define a color array variable called pixels. And we'll go ahead and initialize this on the same line to a new color array where we feed in the number pixel count for the number of elements in the array.
Okay.
Now that we've got this newly created array, we get to the portion that I guess you could consider optional, but I'm going to put in because I like the idea of maintaining whatever data is held in this texture. Now, of course, since we've just created it, we know that they're all transparent pixels.
But if this was changed around where perhaps we fed a texture in.
Exactly, and already had pixel data.
That's right.
It might be useful to go ahead and initialize this pixels array to reflect the actual content of this texture. And that would be a call to the texture's getData method. In getData, we'll go ahead and type the call to a type of color, and then we'll make the actual call feeding the data into the pixels array. Alright, now that we have the pixel data loaded into the array, we can loop through each individual element and set the appropriate pixels based on a random probability.
And if you guys haven't noticed, this is starting to lay out nicely to the plan that we drew over on the whiteboard.
Exactly, like you had said, we're taking a look at things like textures, pixel arrays, and looping through them. As a matter of fact, here we are at the loop. What I'll do is I'll make a for loop, and I'll have that for loop for every element, every number up until pixel count.
Okay.
Now inside of this, we only want to make a very select few of these pixels actual white star pixels. So we need to do a check based on probability. Now we have created this random object, so we can call upon that random object. So if random.nextDouble, I'm going to use nextDouble because we get a convenient value between 0 and 1. And we want to check that returned random value and see if that value is less than our given density value. Because again, we've specified a very low density in this case, 0.001. So it's going to be very rare that this check will come up true. But that's what we want. We want a very sparse field of stars. Now if we have in fact passed this density check, we'll go ahead and set this current pixel to the given color. So of course we're passing in a color up here in the constructor. And we'll go ahead and use that now by saying that the current pixel we're looking at, pixels sub I, is equal to the given color. And then we're not even going to bother putting an else in because we know we've already loaded a bunch of texture data in. At this point we're only modifying certain pixels under a certain random condition.
That's right.
So after we run this for loop, now here comes the new call that we were talking about, because everything we've done up until this point has involved getData. We did things like drawing the ASCII representation of a texture, and then looked at per pixel data, per pixel collision detection, and both of which were revolved around getData. Here we haven't modified any texture data yet. We've modified this color array, but we can take that color array and save it back into the texture. And we can do that by looking at the texture's set data. So this dot texture dot set data, again a typed call just like getData was, so we can go ahead and type that over to color, and then we need to find what array we're going to load the information from, and that will be our pixels array, because pixels has certain pixels set to the given color or a filled star. So this line will actually save this color array back into the texture. And with that, I think that pretty much covers the constructor. Again, its purpose is to make a texture, load up a color array of the appropriate number of pixels, and set some of those pixels, some of those elements to white, and then make sure that that data array is saved back into the texture. Now we can turn our attention to drawing, and then we're very close to testing things. Alright, so over to the draw method for the star field. The key thing that the draw method has to figure out is where on screen the star field should be. It starts out at the top left-hand corner and then advances based on time. And like you had mentioned on the whiteboard, the only value we're interested in is the y value. X is going to always stay at 0.
Right.
So to make this easier to visualize, I'm going to make an integer variable called y.
And we're going to see when you type out the little equation here, our little formula for calculating what y is going to be, and see if they can pick up on how I fibbed just a tad in my drawings. But of course, everybody's going to understand the way I drew it just helped make the whole thing a lot more visual.
I'm actually going to try to build this calculation piece by piece to give a better understanding of why I'm multiplying by so many numbers. So we've got the integer y, and up until this point, all we know is that we want y based on time. Basically, stars advance based on time.
Mm-hmm.
So what is time in this case? Well, it's given by the game time parameter. We're going to use the total game time. We're not worried about elapsed because you just want to look at how many seconds into the game we're looking at. And we'd like to view those seconds as the form of total seconds, as opposed to things like milliseconds or minutes. So if we simply set this, we'll have a very slow advancement. As a matter of fact, if we simply set that, we'll get an error because total seconds is a double, and we're trying to store into an integer.
Exactly.
So we're going to need some casting. Now that does in fact work, but if you think about this is going to be a very slow progression. If we move 1 pixel in y every second, then we have a very slow advancement of stars. But I'm going to leave it like that for a moment until we get a good visual representation of this. I'm going to turn around and go ahead and use our new y value and draw the Starfield texture.
Just draw a single one.
Exactly. So we'll look at our given sprite patch. We'll make a call to draw. We know what texture we're going to draw because we have that stored in a texture field for this instance. And I'm going to draw this out to a rectangle, because that will give the most convenient way of scaling it up to the screen. We just build a rectangle at the position of the full screen. And to do this, we'll make a new rectangle. And we need to specify first x and y for the rectangle. As we had discussed, x is going to stay at 0, so we simply plug 0 into the rectangle's x. Y, we have given by the variable y. Width, we have given by the width and height parameters fed to the draw method. So we can simply drop in width and height, and that finishes off our rectangle. And then the only thing left to feed over to the call to draw is a color, which will give a color of white. Since we've already colored the pixels themselves, we don't need to worry about further modulation.
Right.
All right. This rounds off the call here. I'll build to make sure that there's no errors. And providing nothing else is amiss, we should see some visual result. So if we build and run now, we do see a result. Now, granted, we have an effect that looks more like snow than stars, but that's because we've left the background to the default blue.
Let's change the background real quick, because it is moving. I can see it moving very slowly.
But it's probably really faint with that blue texture. If we change this over to black, we should have a much higher contrast. And if we watch really carefully, every second we see the pixels jump by 1 pixel in advancement.
Yeah.
Though looking at the pixels at this still means we can spend a second just to look at the end result, and we can see that the pixels themselves are actually, you could say, anti-aliased or smoothed or blended into the background as opposed to being those single pixels of the original texture.
Right.
But the first thing we should probably address is the speed at which they move, since they're moving 1 pixel per second, and they're not even taking into account our speed field. So let's take a look at that first. To get an adjustable speed, we could simply multiply by the speed. So we could say this dot speed, and I think we're feeding in a value of 2, so this should make everything move faster, though what is speed? Speed is a float, and we're doing everything by integer. So what I'll probably do is put parentheses around the entire thing, do all the calculations, and then turn that end result into an integer. And, yep, we're moving faster, twice as fast, but twice as fast of incredibly slow is still incredibly slow. So just to prove that it is working, let's do something like set our Starfield speed to 20. And now we can see that we do have a smooth scroll. We could set this all the way up to 200. We have a very fast scroll. Now there's something I don't like about using numbers like this, and that in past videos we had used float-based speeds in the past, but we had updated them every update interval. That means we had used these speed values of things like 2 60 times a second.
Mm-hmm.
I mean 60 times 2 would have been something more like 120. So the expected result of a value of 2 would be about that fast.
That's right.
Here, of course, we have to plug in 120, and why is that? That's because we're using whole seconds, not 60th of a or 60ths of a second, or 60 times a second. Though to emulate that, so we don't have to use a speed that would be different than an on-screen speed, we could leave this at a value of 2 and simply apply the multiplication by 60 here in the calculation, and we get the expected result. Again, here's 2 inside of our star field, and we get that amount of speed. So that way we could set this all the way back to something like even 1, and now we get a smooth progression.
Very nice.
And we also get this in a format where if we'd use our, you could say, our classic speed values, our Starfield speeds would match our actor speeds.
Mm-hmm.
I think I'm going to set that back to 2 for the time being.
But now let's go ahead and run it and let it run for a second. And again, just as we had said on the whiteboard, basically you're going to have all this black come in, and then finally, bink, all black.
And but one thing you'd said on the whiteboard is that the intent for this to snap back on screen. As soon as we go off screen, we snap back to filling the screen.
So let's go ahead and mod it.
We have not done that. And why is that? Well, we're never resetting back onto the top of the screen. We're just continuing in Y forever based on time. If we take this value and modulus it against the given height, that means after we pass this height value, we should reset back to 0. And we can verify that here by watching the screen go more blank, stars get very close to the bottom, and snap back on screen.
Exactly.
So now we have the repeating scrolling Starfield, but a very obvious repeat where they pop back on screen.
Mm-hmm.
Now, the solution to this that you had described on the whiteboard was to draw the texture twice, once at the given Y value and once at one screen height's value above, so that that blank area is always filled with another Starfield.
Mm-hmm.
So let's try that. Let's copy and paste this call to draw and have the second call take our Y value minus our height value. If we do that, then I saw that blank line appear, but I think there's just very few stars at the end of the texture.
Right.
If we regenerate, then we have what looks like a continuous Starfield.
A little bit better. You can also change your density just a tad.
We could do that. We could add some more stars. Let's pull this up to maybe 0.005, so now we have a lot of stars.
Yeah.
Much easier to see.
Yeah, much.
But again, it can't really pick out where the repeat pattern is.
Right.
It just appears to be a continuous Starfield. Now, to underline what's actually happening, to make this look more like it does on the whiteboard, what I'm going to do is momentarily change the call to draw back from the game class. Instead of using screen width and height, I'm going to use Starfield resolution X and Y to draw the actual pixels instead of drawing the scaled pixels. So, of course, this is going to feed in the, what you could say, native resolution of the Starfield. So we should have smaller Starfield squares in the upper left-hand corner of the screen. So there's what it's actually looking like. You can't see above the screen, of course.
Right.
But you can see what below the screen looks like now, where we have two of the textures stacked on top of each other. But as the bottom one hits the very end of height, it wraps back around to the top. So that's what the effect is actually looking like in motion. Could we see past the bottom of the screen? So now we've got that out of the way. Let's turn this back to the screen resolution. So we have screen width and screen height. And let's see, is there anything else I want to set? Really, I think that's getting pretty close to the end of this video because there we have the desired effect. We have a Starfield that is indeed scrolling across the screen. And
we've seen density. So go ahead and demonstrate a really high density.
So what would happen if we used maybe a value of 0.5? So every other pixel should be a star. We get something that looks like solid noise, which is more or less what it is. It is a form of noise.
And it's actually very cool. Again, where is the...
Well, since every line is random, there is no real repeat point.
Exactly. That's what I was going to say. Where is the tiling taking place?
So very cool looking, but not the desired effect.
Boy, there's all sorts of cool things we can do with it.
So, of course, let's say a value of 1 would be completely white. Value of 0.5 we just saw was every other pixel. Value of 0.01 would be 1 in 10 pixels. Still kind of dense, but we run into a scenario where pixels actually butt up next to each other and we get very non-star looking patterns.
Giant exploding stars in the distance.
So once every 10 stars is still too many. How about we do once every 100 stars? I think quite a few, but we still have some of the repeating ones. Though the repeating ones don't look as bad now. They just look like larger stars.
Right.
Or we could go all the way to the original value. I think it was 0.002.
Yeah.
And that gives a very sparse Starfield, but it now looks more like stars.
Very cool. All right. Was there anything else that you were wanting to play with parameter-wise?
I'm thinking just for a moment, but this is the desired effect. The one thing that I wanted to play with was simply to show, well, how I built up this long equation creating the variable y, just showing why we did things like seconds, why we used speed, why we multiplied speed by 16, and showed modulus height is how we get the repeating effect. I had lowered the overall resolution of the Starfield. So I can see
with the mod height, we're not actually moving way off screen to get wrapped back. That's where I fibbed a little bit when I was talking about it earlier.
The moment we just move one pixel off screen, it snaps back up to the top.
Yeah, it's not off, it just snaps.
Exactly.
But, all right. Well, yeah, I guess that pretty much covers everything. I mean, it's really straightforward, and it matches exactly what I said over on the whiteboard. So in the next video, what you got planned?
In the next video, I want to take a look at a multi-layer Starfield, because while I like this effect, it just feels too flat. It still would be a little bit too easy to confuse with snow. What I would like to do is give more of a pseudo 3D feel to the Starfield.
Mm-hmm.
And what I'm going to do to accomplish that is I'm going to have the Starfield Generator managed by, you could say, an encompassing class. And that class's job is to make multiple Starfields. Not just make multiple, but have the subsequent copies of the Starfield be darkened in color, so they're kind of faded out.
Okay.
And also make them move more slowly. Because what you get with when you start to give the illusion of depth, when you have darker stars that move more slowly, it starts to feel like those stars are further away.
Gotcha.
Giving you a pseudo 3D Starfield feel to the whole program.
Okay. Very cool. All right. Well, with that is going to conclude this video. Thanks a lot.